Next up, we have Ajay. So he's going to talk about how his company, he scaled from 500 to 3,500 Linux backend servers.
Hi everyone. So the topic for my talk is majorly I want to share the story from my own experience working as an SRE with Media.net since 3 years and more. So we were at a scale of 500 backend servers, just backend servers. I'm not talking about the monitoring stack or the other tools that we use in order to handle all the operational part of it. So then we scaled today at more than 3,000 servers backend, and at this scale and that many numbers, you will be facing a lot of issues, and you would want them to like sort out so that you can work on real problems rather than redoing or reinventing the wheels by building something of your own. So does this work? I guess no. Cool. So, a little about me. I am responsible for managing our production. So, whenever there are production issues, people reach out to me, and we have to fix all those. Usually, it should be the other way around, and it is. Alerts do reach out to us before anyone else reaches out to us. I am also part of the team where we make sure that our developers have an internal developer platform where they can, as fast as possible, they can develop and deploy their tools and their basically business implementation or the features that they are working on. So this year I also attended KubeCon in Amsterdam. That was a great experience to connect with a lot of CNCF enthusiasts, which are having like same common domain under which we can discuss a lot of things. I am also certified Kubernetes administrator and SRE at media.net. So talking about the history, in 2020 we had close to like we had 3 backend services. Especially, I'm talking about my team only. So and we were running all those on AWS and on-prem with the 500 backend servers. We were using console for service discovery because your load balancers need to know where they need to route the traffic. Post that, we had scripts for moving the logs that are present in the VM or wherever the jars were running. We had scripts to move them to buckets majorly. Then we had for monitoring stack Prometheus and Grafana. That is very go-to and very common thing. Nowadays, after all the evolution we have gone through. And we had HProxy and Nginx for managing all the load that would be like reverse proxying, running as your edge proxy majorly. So today we have like more than 5+ services which are developed by multiple teams. And we are like a bunch of 4 or 5 SREs that are responsible for handling and managing all of that. And now they have scaled up to like 330, 500 and more backend servers when they are scaling. So I'll be sharing our journey from how the basic issues which we used to face while running your backend servers, majorly in our case it was jars majorly, running in your EC2 or any compute VM, virtual VMs, and then how we migrated from there to the present date. Uh, and how we onboarded CNCF projects that helped us in order to optimize all the things that we used to face. So earlier we had deployments that were used to done with some scripts. So there would be a script which will call console to get all the backend IPs. Then it will SSH on into those VMs and pull the jar, stop the service jar, and then add more like get the latest jar and replace it and restart it. Then that used to take a lot of time. So 2+ hours was a basic expected time for the deployment, and that is a significant amount of time because someone has to sit there and monitor till that 2 hours. So you are just sitting idle, hoping that everything goes right. Otherwise, you will have to intervene and see what went wrong. That also had like post that there were scripts to verify because you don't know one of the servers is running a older code and it is not compatible, and then your business folks come to you and say that something is wrong, you need to check, and then you have to really dig dive and see what is actually wrong. and with that infra, we had a very not acceptable. It was acceptable for them because they knew that that was the reality for them at that point of time. So our SLOs were not that great because as an SRE, you would try to achieve as higher as possible. And 95% is not a good number, I would say. So the issues were majorly, so whenever there were downtimes, we used to have longer downtimes. Basically, we don't know what went wrong. So it was a lot of manual effort in order to deep dive and understand what went wrong. So that used to take time. Then your deployment failures, because it is all self-written. So, there would be cases where you will miss a lot of things. Apart from that, there were, again, redundant issues that used to happen. And onboarding new services was a very much pain because you have to manually do a lot of things, spin up all this infra on your own. And observability, let's not talk about that. Very limited matrices, and yeah, that was more or less. So after that, we went on a hustle in order to identify how or what orchestration tool we can use so that we can overcome all these issues. Because your orchestration tool is something that helps you in order to manage, maintain all these things that are happening with your infrastructure and the management part of it. So one of the teams, we had Mesos DCOS, if you have heard of it. So that is also a containerized tool built by Apache. But they were exploring it, and the issue which we used to see was their master used to go down because all the calls and all the actions were taken from the master only. And when your master get overloaded, it is prone to fail and prone to go down. So it was not like whenever the master goes down, your production will go down. But at that point of time, if you want to auto scale, that's not going to happen. So those issues were faced with Mesos DCOS, and it was like little hectic to manage and use. Our team also explored Nomad. That was HashiCorp's new tool at that point of time. It has multiple moving components which we had to manage and deploy in order to take leverage out of all the features that Nomad was providing at that point of time. And that would actually add more management overhead for you as an SRE. So and no, till date, I think not a single cloud vendor is providing Nomad as a service. If I'm not wrong, you can correct me if there is anything like that. Then one of the teams reached out to us that they onboarded Kubernetes and it is working really well for them. And they helped us in order to migrate and everything. And Kubernetes, what we faced was majorly it had a steep learning curve, and it was cloud managed. Like most of the cloud vendors are nowadays, or even at that point of time, were supporting managed clusters, because managing a Kubernetes cluster is a big management task. And it has a extensive community and extensive tools that can help you in order to take leverage of all the advantages, or all the issues that you face can be sorted out with just one tool or like a bunch of tools. So when you have a running production, okay, it has 95% SLOs, but the stakeholders were like, if it is running, don't change it. So you have to convince all the stakeholders that no, we want to change it because it is not good for us, because you are losing your sleep, you are losing your daily patience for managing and doing things over and over and over and again. So for convincing your senior management, what we did was we gave them the reason for why do we actually need it. We told them what are the issues we were facing, what was the time we were spending, or the redundant time we were spending, and or the SLOs and all the numbers that were that could convince them basically, right? So and told them all the benefits, how we will be improving on this stage after after doing this big migration, because it is a very big migration that you have your whole production running at some stage and then you are moving it all to some other place. So senior management is not going to directly approve it if you just ask them, Ki, this is what we want to do. So you have to give them timelines, like how much time you will take, what all steps would be there, what all your failback mechanism would be. and what all consequences will be there if things go wrong. And the other stakeholders for all this is, again, your software engineers whose code is basically running and going to be shipped in that orchestration tool. So again, we have to collaborate with them very closely, because if they disagree, you cannot move it, even if you want to, or even if your senior management is agreeing on this. So to do that, you have to pitch them how their deployment would be easier, what all things they can take leverage out of once you move to this containerization orchestration tool, and they will try to understand you. But our job majorly comes over here is to understand what all issues they think they would be facing and how we can solve them by collaboratively working with them. So initially, we did containerization for them for the first time. Usually what we do is we ask them, please containerize your application, and they're like, will do, but they have their priority, and that priority is to implement the business logic, not to containerize your application. So all those things we did, and then rest of the part we kind of automated. They don't really need to see it, what is happening behind the scenes. Uh, the important part is to keep convincing yourself, because there would be a time where you would be failing and you will be like, okay, let it be. Whatever was working, let's go back and get used to it. But we have to keep trying, and we have to keep giving reasons to ourselves so that we can keep pushing forward until we reach where we want to reach. So you have to think about all the operational ad hocs you do at every day to day your working ethics. So those will go away, and you will be actually working on problems that actually matter, and those are like real engineering problems that you can really contribute to. The other things that would be the infra issues that we used to face, like your one of the backends is not running fine, so you have to go SSH and then restart the service. Those are manual efforts, and nobody want to do that, especially in the middle of the night. So those things you can avoid. Then for deployment, you are writing scripts or developing some own tools which are kind of reinventing the wheel, because there are open source community tools that you can directly take leverage out of, and you don't have to write a single piece of code. You just have to configure them and onboard to your infra. And on-call issues, we all have our black nights. So those, again, used to happen. So is there any way we can target our platform engineering team, their IDP, if we can provide them a tool or a platform where they can develop faster, and they can get the closest to the production environment rather than running everything on their local? So, and the other part would be, again, managing your production infrastructure. So Kubernetes was our final go-to. We decided to go with, and we have to break all this into very small steps, because this is a very big step, and you cannot just directly do all the things in one go. You have to cut down all the small steps and take them one by one, so that it becomes easier for you to target the next step rather than thinking the whole big thing that you are going towards. So containerizing application was the very small step and very initial crucial step that we have to take care of. Once that was done, we had to set up a mirror production, because you cannot hamper your present production in a hope that your Kubernetes is going to work in the one go. Then you will have to test your traffic, collect some data, and present it to your senior management, all the business matrices, all the improvements that you are seeing. In parallel, you can migrate your monitoring stack, basically. That will give all your SREs a comfort or learning way, so that they can also get familiar with the Kubernetes environment of it. Then compare your matrices, show them to your business folks, your product managers, and also to your developers. Post that, there would be some optimizations that you can also pitch in post that, like how can you optimize your compute after moving to containerization system, because you would have a lot more visibility compared to before. And once you reduce the compute resources, that is going to turn into saving the cost, which your business will be very happy to see. Cool. So the features or the built-in things that come with Kubernetes after onboarding Kubernetes is majorly the discovery part of it. They have Kubernetes services, which basically discovers all the pods that are running for an individual service, and you can directly hit them with that service endpoint. It would be automatically having. Then you will also have a auto scaling component, which basically will target your deployment if it based on some metric or some threshold. So based on that, it will trigger your deployment to scale up or scale down. It also provides you readily available health checks. So let's say your application crashed or is going unresponsive. You would never want to send requests to those application pods, right? So those are few things that are unseen, but they help a lot when things go wrong. Then we have the sidecar dependency stack as well, because you run your one service and there are few dependent services that you want to run side by side. Let's say even log rotation, you have a separate container you would like to run with it. So it becomes very easier to onboard and use all those things. Then it also supports, Kubernetes also have config maps, which are basically, so all the applications have a static file where they have the configuration of your, what is your database, database endpoints, or all the application dependent endpoints. So those can be configured in config maps, and your pods can directly refer to them rather than keeping them inside the container image, because then you will have to have regional container images for different regions, because every region will have different endpoints for their databases and other things, right? So that also eased up. Post that, onboarding new applications was like 30 minutes of a task. Now our interns do that every day, and we just review their MRs and that's all. And access management is a pro, which is like RBAC managed Kubernetes is an advanced feature which helps us to give them access so that they can also see uh, what is happening with their application. So the issues which we faced after moving to Kubernetes was, you have a lot of YAMLs, you can kubectl apply, but at one point of time you will think if that YAML was applied before or is there some delta. So either you can run kubediff, but you don't want to do that manually all the time. So you would need some tool to help this. Again, the other issue which we saw was having deployment strategies. So what you can do, what Kubernetes deployment basically do is, they just give you rollover deployment. They don't give you any other feature or strategy to go with. The third thing which we faced was the autoscaler. The HPA used to work on majorly your CPU matrices and all the pod level matrices. Those are system-based matrices. And you would want to autoscale based on something else, like something more advanced. So for the first problem, we onboarded Argo CD. That is again a CNCF project, and it is very popular nowadays. So what it does is basically it connects with your Git repo where all your YAMLs are. It connects with your cluster wherever your control plane of the cluster is, and it just makes sure that things are in sync, and it helps you streamline or your YAML management part of it. For the second part, Argo also has this project Argo Rollout, which basically have blue-green strategy and canary strategy. So let's say for your some DB changes, you would never want to run some pod running with older tag, right? So at that point of time, you can take leverage of blue-green deployment strategies, and rest of the time you can depend on canary-based deployments. So, and then comes the HPA part of it. You want to autoscale based on, let's say, your messaging system, your concurrency, or your application exposing some matrices. So KEDA comes into picture, and it understands all those things, integrates with them, and then creates HPA for you, which can be used, and on using that, your deployment can scale up and scale down. once we were on Kubernetes, it was very easy for us to onboard new tools, new tech stacks, so which can help our developers to get more granularity and more visibility into their application and their system. So we onboarded Loki for rotating or managing their application logs. Then we onboarded tracing with the help of OpenTelemetry. Auto instrumentation for Java is very easy. And to store traces, we use Grafana Tempo. All of this because Grafana has integration between your matrices, your logs, and your traces. So it becomes very easy to point out, let's say there is a spike, you click it there, it will show you logs and as well as your traces. So you know what happened wrong and it is readily available. The last component which we added was Sentry. So there are redundant issues or redundant errors that are thrown by your application. And there needs to be a place where you can log all of this and you can actually trigger alerts based on that. So Sentry takes care of all these things and it helped our developers to understand exactly at which line of code things went wrong. So when you scale from 500 pods to this large infra, there would be more issues you would be facing, which would not be about managing the production, but more than that. So catching up with the scaling of the traffic. So our traffic used to scale very aggressively, while our auto scaling was not that aggressive. So we switched from CPU or QPM-based concurrency to QPM-based auto scaling to concurrency-based auto scaling because concurrency is one of the volatile metric which you can rely on whenever there is bombardment of traffic or high load on your application. Then we faced an issue where we ran out of pod IPs and GCP basically have this logic of like each node will be reserving close to double of what the number of pods that can run on it. So we had like 60 IPs reserved for each node and we ended up losing all the IPs, but you can assign, we have to then use additional subnet and that more or less fixed our issue. Then one of our data centers, Prometheus, ran out of memory because it was like 50% of our whole production and we were emitting a lot of matrices. So then we onboarded Mimir, that is also a Grafana created tool. So Mimir basically takes care of handling all the post matrices and we keep our alerting on Prometheus because you would want to be as close as to the origin of your matrices in order to trigger any alerts. Because if you put more components in between and they go wrong, you don't know, you cannot expect the alert to come in that scenarios. The next issue which we faced was like we were running 16 core backend pods and whenever they used to scale up, it was running Java and Java has this issue of lazy loading of classes. So whenever they used to scale up and new pod used to come up, they were bombarded with 300 QPS or plus, and for at least 5 minutes, they were trashing that traffic completely. So we wanted to have something that could slow start or slowly, gradually send the traffic to those new pods that came up. Next issue we saw was service discovery. So console has a inbuilt close to like 2 minutes of delay for service discovery that is hard coded in their code. So our Nginx used to get the IPs with the delay of 2 minutes, even if our console agent and console is discovering them slightly faster. But there was a delay, which was like when you are scaling very aggressively, you cannot afford that to happen. So then we ended up deciding to, okay, let's get rid of console and Nginx if there are any open source load balancer that can help us. So if I break down what a load balancer's job is, basically, it has two things to do. One is to load balance between all the backends based on the second part, that is whatever configuration you have given. So you can say that the load balancing part is nothing but your data plane and the logic based on which it has to route or handle the request, that is your control plane. So Envoy, we found out that Envoy is Lyft created very advanced tool which supports all of these. That also involves slow start, which can like gradually send traffic. Nginx and all does not support this natively. You can definitely build wrappers on top of it. But that would be like reinventing the wheel, right? Uh, NOI has one more advanced feature, that is XDS. So you can basically inject your configuration to a running NOI, and it will readily update itself with the injected configuration. So you don't need to restart your VM, or you don't need to do anything. You just have to update your config, and it will be readily available in your load balancer. And Envoy natively supports compression, decompression, tracing, exposes matrices, and it also has rate limiting functions. So, and Envoy proxy is nothing but the core of all your Istio, Kong, Ambassador, and Go, Glue, all those service meshes you would have heard of, or all your gateways, load balancers that are built on top of it. So, yeah. So for our use case, we did not want to use Google managed, or let's say your ALB, NLB, or Google managed load balancers, because that costs very much when you have a high scale of traffic. So we prefer to get traffic directly hit on our VM. And if you want to take the traffic directly to your cluster, it is not possible without placing any NLB, ALB. So we had a hard rule that we have to run our load balancers on VM only, which will have public IP for sure. So we knew that Envoy was the solution for all our problems, but how do we configure it? So we ended up creating one of our in-house control planes, which used to run in the cluster, because inside cluster you can discover all your backend pods and then inject the configuration to your VM. But that did not go well, because you know how in-house tools are. They will have a lot of issues, and you cannot directly go and use them to production. So we researched on what all options are there for open source control planes which can provide all these features readily that Envoy is capable of. So we ended up with Istio. So Istio is majorly famous for its service mesh thingy. So what it basically does is run a sidecar container as proxy, and takes care of all the traffic incoming and outgoing. But we wanted to use it as a edge proxy, and literally there is no documentation to do so. So I ended up discussing with the maintainers of this community, and they told me that they have a router configuration which you can use. So we basically deployed Istio VMs in our VM, tweaked the configuration so that it acts as a load balancer rather than a sidecar. And this works for us. And to inject the configuration, you just have to write the envoy filters, which will be readily injected to all your VMs. You don't have to use Puppet or Ansible to configure your VMs for that configuration. You just have to apply your envoy filters that would be applied in the cluster as YAML, and it will be readily injected to your VMs. Those are running Istio. So that is the journey we had. Thank you. Any questions? Cool. Thank you, everyone.
Thank you so much, Ajay.